What we have to do today, we have to go to some remaining issues related to use of arrays, and to do some conclusion of this class and to show what's going to be on exam. So this is typical for all terminating classes. So let us first take a look of this array program here, where we have to compute square of components of array. So it is possible to process array in situ. So when I have an array A that is passed to this square program, A length times is going to give me indices from 0 through n, and then A of I is A of I squared. So I'm modifying this array and returning that array. So both things are done here. This show program is displaying the array. So it is saying print array equal, and then if array is empty, if there is nothing inside, then we say empty array. Else, for any element in array, display this array and put space between them. So what I'm going to have is the message array and then equals, and then components of array, like here, array equals 1, 4, 9, 16. So in the main program, we define array 1, 2, 3, 4, and then show the original array. So original array equals 1, 2, 3, 4. So original array equals 1, 2, 3, 4. Here is the result. Now, I want to square this array. So I say B equals square array. So what you have here is that this array is modified, and at the same time is this returned from this program. So since it is returned, can be assigned to array B. So B is going to be equal to A. And then we show that B. So showing B is returned array is 1, 4, 9, 16. When I say show array, the original one, modified array is also 1, 4, 9, 16. When you assign array to array, you assign only pointers. But you have that this is the same thing. An array is modified in place in situ. Now, modified equals returned if B equals array. Of course, they are equals because they are equal pointer-wise, and therefore you get that modified equals returned. You can continue modifying array in place. So square of array another time. So we have this array 1, 4, 9, 16. We are now squaring that and showing array, giving me new arrays 1, 16, 81, etc. So these are again squares of all these previously squared numbers. If you ask what is the class of this array, it is of course array, and length is 4, the same that was originally. Now, it is possible to use array in method calls. So list of scalar arguments can be replaced by components of arrays and their parts. So if you do that, you should use asterisk, which is called splat operator, so that you distribute components of array to arguments of the program. So the number of arguments must be correct, but there is also possibility, like in scheme, to have arguments that are bundled into an array, and then you can process that array. So Ruby has more capabilities than scheme in that sense, and here is example how this works. So this is a very simple demo program that has arguments A, B, C, D, E, F, and then it's just displaying them, A and B and C and D and E and F. So the question is, what are we going to put in these arguments? Well, the first thing that I can do, I can create here an array that has 6 components. And now you can replace A, B, C, D, E, F with numerical values. So you have demo of 1, 2, 3, 4, 5, 6, 6 of them. And then you're going to get this displayed result, 1, 2, 3, 4, 5, 6. Or you can say demo and put here splat array. So this array is now decomposed, and component 1 is stored in A, component 2 in B, component 3 in C, and component 6 in F. So if you say a splat array, you get 1, 2, 3, 4, 5, 6 the same way. So the array is decomposed and stored in these scalar variables, arguments of this function. You can also put a constant array like here and say splat this, decompose that, and put it in these arguments. Or you can do that as a range. So this is a shorter way to say from 1 through n, make this range and then convert it to array, and then after that put splat of that. So when you splat that, you get all these arguments. Again, the same thing. Or partially, you can say 1, 2. 1, 2 is substituting I and B. And then you have 3, 4, 5, 6 that comes from this range, converted to array, and then decomposed as arguments of this function. So all this is giving you possibilities of very, very flexible way of putting arguments. All of them give you 1, 2, 3, 4, 5, 6 the same result. Array can be heterogeneous, so I have 1, 2, 3, 4, 5, 6, where I mix integers and strings. And when we splat that, it is going to get inside and be displayed 1, 2, 3, 4, 5, 6. So there is nothing more that could be done that cannot be done here. So it is fully flexible, and all combinations are possible. The method with arbitrary number of arguments can be made exactly the same way as in scheme. And you can have any arbitrary number of arguments, or you can have the possibility to have mandatory and optional arguments, same as in scheme. So in the case of this demo program that is returning arguments, you say, I have here an arbitrary number of arguments. So splat arg, that means you can put here an array that has any number of components. So this is practically any number of arguments that you can put in this demo program. So if you say A equals demo of 1, 2, 3, 4, when you show that, you are going to show array equals 1, 2, 3, 4. So there are 4 arguments, but you can put 6 or any number of them. So show program will say array equals, and then if it is empty, then say empty array. In all other cases, show all components and put a little bit of space at the end. So that's typical show program. And then if I have 4 arguments, that's okay. If I ask what is the class of this A that is created in this way with this demo program, because it is returned, it is an array. It is array class, and the length is 4. Now, you can say also, I'm creating an array that is demo of an empty list of arguments. Well, empty list of arguments is creating an empty array. Therefore, when you say show A, you say A is empty array. If you have here that you want to see what is the class, empty array is an array, and A class is array, and length is 0. So empty array is an array that has length 0. Splat operator can be used to combine mandatory and optional arguments. So if I have here call max of first and rest, first is mandatory, rest is optional. But you can have first, second, and then rest, in which case first and second are mandatory and rest is optional. So it is literal copy of the concept from scheme, and it is support for functional programming, obviously, that you can have all these tricks with different arguments that you can use. This program is computing the maximum of this list of arguments. So initially, I put maximum to be equal to the first one, and then this array rest each, take each of them, put it in X, and then max is X if X is greater than max. So this is iteration that is iterating for each component, taking the maximum value if X is greater than maximum. And then I return maximum from this program. If you want to compute maximum and minimum to show that you can return two variables, which is an array with two components, you can put max min to be the first of them, and then rest each. So these are optional. Rest each, put it in this variable X, and then max is X is greater than max, or min is X if X is less than minimum, and then return max and minimum. In the case of max that has two mandatory variables, then of course, you have first to see which one is bigger of this first and second. So if first is greater than second, return first, otherwise return second, and put that in max. And then rest each, for rest of them, see what is greater than the max. You can also decompose this into head and tail. You can say head and tail are here. So you turn head and tail. It is possible to do that same as in scheme, because this is obviously a copy of the concept that we have seen in scheme. So you say, give me maximum of 1, and this is obviously only 1. So print is going to give you 1. Give me maximum of 1, 2 is going to be 2. Or maximum of 1, 2 with two variables, where again rest is empty, is also 2. So this works properly. But if you say, give me a maximum of, say, 1, 2, 3, then the first is 1, 2, 3, and the rest is empty. So practically what you have here is that you apply this array as the first component. So this is different than before. If I have here A, which is 1, 2, 3, 4, I can say here is the first one and the rest is 2, 3, 4. And we have here a few more examples that are using that. But the basic thing is that you can have mandatory and optional arguments. First, second is mandatory, rest is optional. Arrays have other nice features, and to summarize them, array indexing starts at 0. Array uses circular indexing. If you say component -1 is the last element of array, since the first one is 0, then there is the circle. With -1, you jump to the end of array. So it is circular list. You go 0, 1, 2 through n-1. But if you start with -1, you get n-1. With -2, n-2, n-3, n-4. So with negative indices, you can go from the last component to the first. So you can go either from the first to the last or from the last to the first with negative indices. Array elements can have different data types, same as in scheme. We can have heterogeneous data types inside array. Array new has the possibility to create an empty array. So array new is equivalent to A equals empty array. But you can also say create array that has n empty components. So create array that has 5 components and all of them are empty initially. Or you can instantiate them in some way. With A of value index, you can get either the object that is here, or if you are out of bounds, you get nil. So you are not going to create out of bounds errors, but you know that you are out of bounds because you returned nil, and you can check that. Then you have the possibility to take a subarray, any subarray, either by saying from component start and then take length component. So if I say from component 3 components, then you're going to get the component 3, 4, and 5, 3 components. You can say components from any P through any Q. So you have the range from P to Q. So you're cutting a segment of your array. Here is an example how we make an array. So an array new that has so make array program has argument size. So I say array new of size is creating an array that has a size components 0, 1, 2, 3 up to size -1. Now, if you leave it without this rand, you are going to get that this array will have simply the size components. But if you put here the value, then these values are going to be stored in these components. So what is the value? The value is here, random number between 0 and 9. So I'm going to fill that with random numbers. What's the reason for that? I want to see what is the quality of random number generator. So what I'm going to have here is A equals make array of 200. And then when I create these 200 numbers, I want to show that array. Since there is this little space, I'm going to go from 0 up to A length -2, and I'm going to write also, is this array sorted or not? So show is going to go from 0 through n-1, will display all components after 20 of them in the row. If I plus 1 modulo 20 is 0, I have 20 in the row, put string, otherwise print. So we are printing 2, 5, 3, 7. When we come here to 20th, go to new lines. So this is how I make this output here. Show A is creating this array. And after that, I have recognizer. Is the array sorted? So going from 0 to length -2, I'm checking whether A of I is greater than A of I plus 1. It should not be. If A of I is greater, then array is not sorted. And then I return from here by giving this message. Otherwise, if all of them are sorted, I return the message array is sorted and go out from there. So when I show this array of 200, so this is here, the array, then I ask, is this array sorted? It is not. So array is not sorted. Then we apply in situ sort. So sort with exclamation point is applied to A. It is internally sorting A and creating an increasing sequence of values. And then when I show that, I get this value here, all zeros, ones, twos, etc. Is this sorted? Yes, it is. So this here gives me the distribution of digits, 0, 1, 2, 3. All of them should be distributed uniformly if I have long sequence. Of course, this sequence of 200 is short. Therefore, you don't have ideal distribution. But for example, if you look 7, it has indeed 27s. But if you look 8, there is shortage of 8s. But if you have a surplus of zeros, you have 3 more than necessary. In the case of ones, you have 1 more than necessary. Twos, also, you have more than necessary. So this is, of course, not ideally uniform distribution, but you have zeros, ones, twos, threes, 4, 5, all of them, except that they are not perfectly uniform distributed. If you have not 200 number, but 200,000 numbers, then you are going to get completely flat distribution because you have the law of large numbers is going to give you this uniform distribution. Here, the distribution is not ideal, but the number of values in this sample is small. Now, here is another example of showing arrays. I want to make homemade show array program that works same as kernel method P. So what I do to show array, put first bracket. So I want to show array as bracket and then A, B, C, 1, 2, 3, whatever is inside, and closing bracket. So I have to put entry bracket and then A length times print A of I. So you have here I, which is index of this times iteration. Print A of I is printing first, second, and all of them. And then if we have A length -1, then we are putting a comma in last case. When you get to length -1, then you put right bracket. So this is first bracket, then this is comma, 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 and at the end, last bracket. So I have here ABC 1, 2, 3 that is given as an array. And then B equals A is copying A to B. Then I show A and show B. Of course, they should be ABC 1, 2, 3. And then after that, if you want to display A of 10, what we do now, we are out of bounds because we created an array that has 6 components. Out of bounds is 10. So when you display that, you get nil. There is nothing inside. You can have 3 elements starting from 2. So this is 0, 1, 2. And 3 elements from here is C1, 2. So here is C1, 2. You can do it in this way, or you can say A from 2 to 4, or whatever else you want to do. Or you can say array new of 5 components. Where you show that array, you get nil, nil, nil 5 times. You can say array new filled with zeros, 0, 0, 0. You can fill that with strings. You have array new 5 components. No, 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 no. Or even expressions are possible. You can say you create array new. So put index of array in this K, and then put inside the value of K. So this is going to be 0, 1, 2, 3, 4. Or you can even put expression. You can say put in this array squares. So take class array, use method new, create array that has 5 components. For each component K, put inside K square, and you get 1, 0, 1, 4, 9, 16. So things like that in a single line are absolutely not possible in languages like C++ or similar procedural languages. Here is this done in a very elegant way where you have a class and method and instantiation all in the same line together with showing the results. Pay attention always that if you have interactive Ruby, that you are having a functional language. So if I say A is 1, 2, 3, 4, 5, this returns a value. This is expression that returns a value. The value is 1, 2, 3, 4, 5. If I say print A, then print A has a side effect. Side effect is this printing, and returned value is this nil. That's why you have a side effect and nil. Put string is giving you 1, 2, 3, 4, 5 and returning nil because this is side effect. In the case of kernel method P, it is having you this side effect and returning the object itself. If you say B equals A, you are copying the pointer, so you get 1, 2, 3, 4, 5. So if I now take A of 2, so A is the array 1, 2, 3, 4, 5. Now I take A of 2 and replace it with 3, 3, 3, 3. So this 3 is now replaced with 3, 3, 3, 3. If I say show me A is 1, 2, 3, 3, 3, 4, 5. But if I say show me B, you have the same thing. So practically A is equal B because we copied the pointer, not the whole file. So by modifying one component, we modified component in the other array because both of them are pointing to the same object in memory. So this is clear, but I want you to know that. There are plenty of instance methods with arrays. First, some instance methods are used for performing set operations. So all set operations create sets. We have also repetition, concatenation, difference, append, and comparison of objects with this compare matching operator. So matching operator returns -1 if A is less than B, 0 if they are the same, +1 if B is greater than 1. Okay, and if A is greater than B, sorry, if A is greater than B, then returns 1. If it is less than B, -1. If it is equal, 0. Or nil if they are not comparable. You can also equate arrays to see are they the same or not. We also have include, delete, clear, reverse, first, each, sort, transpose, and plenty of other things. Convert to array and convert to string. So let us see how this works. In particular, I am interested to show you the way how sets work. So the complete set algebra is possible. And if I have 1, 3, 5, 7, I can say this is an array that plays the role of set. And if I apply conjunction and operator between 1, 3, 5, 7 and 2, 4, 6, 8, these are two disjoint sets. So what I'm going to get as the result is an empty set. So when I say show, I'm going to get an empty set. So I have the empty set that has nothing inside. If I have some common elements like 1, 2, 3, 4, 5, and here 4, 5, 6, 7, 8, then 4 and 5 is intersection of these two sets. And this is the result of intersection. However, if I have arrays that are not sets because they have repeated elements like 1, 2, 1, 2, 3, 5, and here 1, 3, 3, 3, this is again going to create a set. So what is going to be the set? Those elements that exist in both of these sets. So what exists in common is 1 and 3 that exist inside. So you have 1 and 3 that exist inside, and you get 1, 3 that is the result. So this is again creating the result without duplication, without duplicates. So it eliminates duplicates, same what we had in Prolog when we eliminated duplicates. Now, union is doing the same thing. 1, 3, 5, 7 and 2, 4, 6, 8 is creating all of them. Okay, but if I have common elements like 4, 5, 4, 5, 4, 5 is not going to be duplicated. It is shown only once. 1, 2, 1, 2, 3, 5, and 1, 3, 3, 3, 3 is going to give you 1, 2, 3, 5, which is set, where each component occurs only once. Concatenation of arrays is not union. So if you concatenate two array with plus, you simply say array plus array, and you get all components that are in first and second, and they can repeat any number of times. So if we have here 1, 2, 3, 4, 5, and 4, 5, this 4, 5, 4, 5 repeats twice. So you simply glue them together without any thinking what is inside. Same with this two here. Difference of arrays is having this array that has 1, 2, and 3 repeated, minus 1, 3. So remove from this array everything that is equal to 1 and everything that is equal to 3. What remains? What remains is 2, 2, and 3, 3. 2, 2, and 4, 4, because 1 and 3 is removed. So 2, 2, and 4, 4. You can have also repetitions of array. If you say yes times 3, you get yes, yes, yes. Or you can put inside this string. So here is the possibility to multiply string times string. And when you do that, you insert this string inside this array of components. Set operations create sets. That is important. Set operation here and set operation. Conjunction and disjunction, or and or, they create sets. We have also possibility to create struct. Struct is something that is literally taken from C or C++. You have also an attempt to make Ruby first-class object. In order to be first class, among many other conditions, you have to be able to show objects in human readable form. So Ruby has a method called inspect. That belongs to object, of course, inherited from object. And this inspect is taking an object and presenting that object in human readable form. This is not beautiful, this is not well structured, but it is showing something that you can read. And therefore, object.inspect is showing that in readable form. If you then put string object.inspect, because object.inspect returns string. So it puts string, you display this human readable form. To avoid writing put string and inspect, this is abbreviated with P. So P object is same as put string object inspect. Now, if I create a struct new has three components: author, title, and publisher, written again with column here. So struct new with this syntax can define a book. So you say book is an object that is a class, practically. This is a class that is created as struct new that has these three components. These are internal variables. And then you can say class book, instantiate JD600 reader Wiley, and then you say, what is book class? It is class, of course. Then after that, if you ask to inspect that, it is again class is book. And then you can say PB, show me this struct. And it says struct book, author equals, title equals, publisher equals. It is not particularly beautiful, but you get this in human readable form. You can then take, of course, if you want b.title, then b.title will be 600 reader. And then you have the object, and then dot is component from here. It is struct. This is not going to be the method, but it is going to give you the first component. If you have multiple components, if you say print 1 divided by 3 and 1 divided by 3, it is going to print this as an array. Pay attention that when you do real numbers, you have to put 1.03.0, and then you get 0.333. If you have 1 divided by 3, then you are going to get 0, because this is integer division. Now, this is very important to understand that when we write programs with dynamically typed objects, we must have proper data types that we put inside. Because if you have program that has variables, no variable has data type. So what is the data type depends on the result that comes from the value of argument that you put in variables. So you have to put, for real numbers, you have to put real numbers. You cannot say 1 is same as 1.0. These are two completely different things and have completely different consequences. So this is a consequence of programming with dynamically typed objects. So this here is the same slide as this one here, but here we use our homemade program show, and here we use P. The results are identical, exactly the same. So this is just showing how the P works. It is possible also to append objects to array, either by pushing inside or by appending with this operator that looks like insert object in a stream. So you have here array 1, 2, and then you append object. And when you do that, you get 1, 2, and object. You can also say, I have 1, 2, and I'm going to append object A, object B, object C. And then you get the total 1, 2, A, B, C. If you you append a single object. So if I put here two things that are array, this is going to make 1, 2, 3, 4. So it is going to append this object to 1 and 2. And the length of this is going to be 3. We can compare 1 to 3 and 1 to 4. And 1 to 4 is greater than 1 to 3 because 4 is greater than 3. Therefore, you are going to get that 1 to 3 is less than 1 to 4, therefore minus 1. If we ask, is 1, 2, 3 less or greater than 1, 2, 2, it is greater than, therefore plus 1. 1, 2, 3 can be compared with 1, 2, 3a, and it is less than 1, 2, 3a because numbers are the same, but this is the longer value. So it is shorter or longer. This one is less than this one here. So it returns -1. A, B, and 1, 2, 3 are not comparable. These are two strings, and these here are two numbers. Result is nil. You can ask whether two empty arrays are equal to or greater than or less than, they are equal. But if you ask if they are equal with relational operator, this returns true or false. So this here returns 0 because that is equal here, and this returns true because it is true. So this is logic operator, this is 0. And then you can have also comparison of arrays. 1, 2, 3, is it equal to 1, 2, 3? Yes, it is. 1, 2, 3, is it equal to 3 to 1? No, it is not, because these are not equality of sets. This is false here. You can, of course, sort that, and then you will have the possibility to use equality. If you have 1, 2, 3, 4, 5, 6 array, you can say, give me array at component -1 and -2. -1 is 6, this is 5. 6 and 5 are here. Then you can take from this array and delete one component. You have array 1, 2, 3, 4, 5, 6, you delete 4. When you show this array, you are going to get 1, 2, 3, 4 is missing, 5 is here. You can reverse that array. So array reverse is reversing 6, 5, 3, 2, 1. You can ask whether 3 is included in that array, and the result is true. Yes, it is part of that array. It is here. Okay. Is it 4 component of this array? We just deleted 4. The answer is false. It is not there. Okay. And then you can also do other operations. And here is a couple of examples. So if you have A that is 1, 2, 3, it returns 1, 2, 3. This is now interactive Ruby. A times 2, array times 2, it gives you 2 times the same array, 1, 2, 3, 1, 2, 3. 3 times array, 1, 2, 3, 1, 2, 3, 1, 2, 3, 3 times. If you ask whether A is A, yes, it is true. If compared with A is the same, 0, yes, it is. If you say A is 3, 2, 1, it is not, because A is different here. You can say, is A, which is 1, 2, 3, is it equal to 3 to 1 sorted? Yes, it is. So this is the way how to see whether two sets are the same. Sort the first set, sort the second, and ask, are they the same? So this is true. A is 2 times A. Now you get A that is 1, 2, 3, 1, 2, 3. When you sort that, you get 1, 1, 2, 2, 3, 3. You can then say A or A. This is going to eliminate duplicates, and you are going to get 1, 2, 3. From this 1, 1, 2, 2, 3, 3, you get 1, 2, 3. When you eliminate duplicates once again, you get the same thing. So nothing is changed. If you take A of 0, this is first component. A1 is second component. A minus 1 is last component. Minus 2 is this 2. Minus 3 is the first component, 1. Minus 4 is out of bounds because you go out. So minus 4 is out of bounds, same as 4. Both 4 and minus 4 are out of bounds. They are nil. Reverse is 3, 2, 1. A is A plus A reverse. You get 1, 2, 3, 3, 2, 1. Then you can ask whether A is equal A reverse. Obviously, this is a palindrome. The result is 3. So you can say, put palindrome. If A is A reverse, you get palindrome. So this is playing games with arrays, and they are indexing. This shows plenty of freedom and flexibility that you have. Everything here is working. There is no any limitation what you cannot do here. Then here is an example that we used in procedural programming. It is matrix multiplication. The matrices are stored as arrays of array. So if you have matrix 5895, so it is having two rows. First row is 58, the second is 95. So you can make array new that consists of array new. So you have array of array. And then if I want to multiply matrix time matrix, I have three loops, I, j, and k loop, and then I make this dot product here. So this is what we did in procedural programming, and we can multiply matrices in a simple way. Then there are a couple of slides that are just measuring time, how fast is matrix multiplication. It can be used as benchmark. So I have here start time is time new, and then matrix multiplication, and again end time is time new. So when you say end time minus start time, you get the runtime. So runtime is whatever is here, 1 second, and then you do the same thing in C++ to see how many times procedural language compiled is faster than one that is executed on virtual machine. This is a little slower, of course. And then here is another measurement of time. And here is the possibility to use tail recursion in Ruby. How to make the tail? The tail is tail of array A. So you have array A, and you return A from 1 through A length minus 1. So when you take this array that you return, it is practically everything except the first component. So I can use that in the same way we use that in all tailor recursive programs. So you can say, if I want to sum components of array, I have that if length is 0, I return 0. This is boundary condition. In all other cases, I return the first component plus the sum of tail. So sum of the whole list is head of list plus sum of the tail. So literal tail recursion, there is absolutely nothing new inside. So if I have A that is 1, 2, 3, 4, if you say print A is 1, 2, 3, 4, what is the sum of A is 10, 1 plus 2 plus 3 plus 4. And you can combine that in all other ways. You can say tail of the tail. Okay, so tail of the tail is, of course, 3, 4. Okay, sum is 7. So tail recursion works in Ruby in same way as in Scheme. Now there is one important thing to emphasize. In all object-oriented languages, we have that we create objects. Objects have instance variables, but they have plenty of other things inside, because object, for example, in Ruby is inheriting properties from the root object that has inside other things. So object takes substantial memory. And if you compare, if you copy object from one place to another, the question is how to copy that. Are you going to copy all this auxiliary data that comes with instance variables, or only instance variables, or nothing of that? So there are 3 ways how to do that. The first is to copy pointers. This is assignment. Object 2 equals object 1 is not copying objects. It is simply putting pointer to object 2. So this works perfectly, but object 2 has pointer same as object 1. The object in memory is only single object. There is no copy of that. Now, if you want to duplicate in Ruby, there are 2 possibilities, duplicate and clone. Clone copies the full object, including all internal state of object 1. For example, if you have each is tagging internally the object. So if you have tagged object, you can have this tag that is also copied if you want to have that. So object 2 is object 1 clone, is copying absolutely brutally everything that you have to the last bit. Okay. Duplicate, as opposed to that, is shallow copy of instance variables. So you take instance variables and put instance variables. You create an object with instance variables, but the object does not have internal state of the object. This is not flags, and referenced values inside are not included. So this is beautiful that you have three completely different ways of copying pointers, duplicating instance variables, and cloning everything. Assignment, duplicate, and clone are three ways. And this should be looked for in each and every object-oriented language, because these are three ways how to deal with objects. And this is very explicitly visible in Ruby. Here is one program that is showing A is a dup, and B is a clone, and the results. And then, of course, when you change one, you change the other if it is with pointers, otherwise they are independent. Now, with Ruby, we have to study a few things that we were not studying before, and these are first elements of input-output. So I have to do that. Before that, I want to show you this example here, which is also included in that file preparation for final exam, because this is a typical example that we have on final exam. This is taken from final exam. So the question was, create a class set and methods show, found, has, member, and is set, recognizer for set. So class set starts here, terminates here, and I have inside initialization of a set. Of course, this is done with splat operator. So you can have, you initialize here with an array of components, and you can say I'm initializing this with 1, 2, 3, for example. So you have internal array, which is A, that takes this array that is given here. So this is splat operator. First is going to first, second to second, third to third, etc. So A class returns an array, obviously. So this is going to be the set. Now, I want to show this set. The set in mathematics is written with curly braces. So set that has 1, 2, 3 must have curly brace, and then 1, 2, 3, and curly brace. So I ask you to write the program that is displaying this. So the first thing in show program, you have to put left brace, and then A length times, you are printing this A. And if it is not the last component, you have to put comma. Between all of them, you have to put comma. If it is last component, then you print the right brace. So you have component, comma, component, etc. And the last component is terminated with brace, and you get 1, 2, 3. So this is a show program. And then I have to say whether component A is found inside this array A. Well, you can use include if you know that it exists, include with question mark, or you can go through the loop and ask, is this A inside or not, which is done with loop. That would be different way, but I have only include here. Then has member is the same thing. You say print X is or is not member, and you say is not unless A is included in X is included in A. So whether X is member of set A, and then you write is member or is not a member of the array, and this is self show. You can apply show to self, and then you have the message like 3 is a member of 1, 2, 3, or 4 is not a member of 1, 2, 3. Another thing, you have to check whether something is a set. And this is a very elegant way of doing that, because I know that logic operators like disjunction or are eliminating the duplicates. So something is a set if all elements are different. Therefore, when I say A or A, this is going to give me A without duplicates. And if there are no duplicates, then A or A length is equal to A length. And this is true or false that I return from this is set. So if I have is set, for example, something that has duplicated elements, this is going to tell me false. It is not. But is the set this tree true? Yes, it has only one element in set. You create a new set that is empty. Is it set? Yes, it is, because it is empty. Empty is equal to empty. Elements of input output are first command line arguments. That's what I want to show you now. And then you can take data from keyboard or from files. And let us see how this works. Keyboard input and command line are processed in identical way as in C++ or in C. So what you have is that you want to write a program that is computing the mean value of these command line arguments, 1, 4, and 5. So at the command prompt, you say Ruby, and then after that, the name of your program, command line arguments.ruby. So that's my program. And these are arguments of my program, 1, 4, and 5. So what's going to happen with command line arguments? Ruby is going to read them in argument vector, which is default name, argument vector of 0, 1, 3. And I have 3 of them. All of them, same as in C++, are read as strings. Therefore, since these are strings, I have to compute ABC numerical value, I have to convert that to float, to double precision float. So I say A is argument of 0 to float, B is argument of 1 to float, argument of 2 to float is C. So I have ABC. So I can now write the result, mean value of A to S to show that this A is float. So 1, 0, B to S is this second to 0, C to S is this 5, 1, 4, and 5. And then the result is A plus B plus C divided by 3 converted to S. It is 1 to 3. Pay attention that this here is float, float, float. This here is integer. It should be written 3.0. But if you put only 3, it is going to be automatically promoted to real value, and this is going to be real division. When you get that, you get this double precision floating point number, convert this to string, and concatenate with these strings inside, put string. And then you get this message here. It is trivial. It works identically to C++. Nothing is different. Except that C++ you have to put argument vector in command line in main program arguments. Here it is by default called argument vector. What is better? You don't have to write this same thing always over and over again. So argument vector written in capital letters. Here you have a dialogue with the user. So the first thing I print, enter your name. And then I read with get string. Get string is reading the string and putting that in name. And then say hello name. Okay? So enter your name, Ruby. Then I say hello Ruby. And then comes prompt, enter the first number. And the user enters 1.1111. So this is first number, get string. It is read as a string and then converted to float. So get string, convert to float, and put in first. Enter the second number, get string, convert to float. And then you can say what you are going to do with these two values. For example, select 1, 2, 3, 4 for addition, subtraction, multiplication, division. And then you have operator. Operator get strings, convert to float. And then when you convert it to float, if it is 1, then compute addition. If it is 4, then compute division. So if I enter here 4, it is going to divide 1 divided by 2 will give me 0.5. You selected division. And you can continue in this way. So this is the program that is reading with getString. Now, In Ruby, the parentheses are optional. This is to be similar to procedural languages when you have function, argument, argument. But you can say also in scheme, this is operator, operand, operand. Operator is print, operand is hello, and name. So you can say print hello name without parentheses. So here you have the same program written in two different ways. This is identical program. This here is without parentheses. This is one with parentheses. What to do? Well, it depends what you like more. If you want to say get S, get string, convert to F, you can write it this way. If you want it to be similar to functions, say this is function without arguments. So you can do it in any way you want. Ruby will understand you without problems. Working with files is similar in all languages, and it is equally boring in Ruby as it is boring in Scheme. Working with files is always using text files line by line. And of course, Ruby has other possibilities. There is a dir class for manipulating directories. So you can say change directory. So go from this directory to user Bill Ruby, or print working directory will tell you what is your current working directory. We'll say user Peter Ruby. You can make directory. You can say make directory, users will scheme, remove directory, and all its constants, user will Pascal. You can have file class that is creating file, opening, renaming, and deleting. What is done in all languages with all files. So when you open the file, you say file is file new, and you put here the name of the file. And if you want want to specify what you want to do with file, then you write it here as the second argument. Read is open for read only. Start from the beginning, read only. You cannot write inside. You could, if you say W, say write only. So overwrite an existing file for writing. Append. Take a file, put pointer at end of file, and keep appending new records to it. And then you can have R plus W plus A plus if you want to read, write, and combine other operation. If you are under DOS, you can also have binary file mode to take just binary files, not text files, binary files. Open close, if you open file data.txt in working directory, then this is now internal name. You can have each that is taking lines, and then you can display these lines. You can close the file, you can open the file if file exists. This is a beautiful thing, that you never open file if the file does not exist, because otherwise you create a runtime error. So you first check whether the file exists. If file exists, open it. If it doesn't exist, don't open it, because you want to open for reading, and you cannot read from non-existing file. Rename file data.txt to junk.txt. After that, file delete junk.txt. You delete that file. Ask whether file is closed. Return true or false. File is size. Returns size in bytes. This is useful to know how big the files are. Example that we already had. File open. Here is text file.txt, and put internal name in F. And then F each line, print line, and then you with each first line, second line, last line, this each sooner or later will hit where? In end of file marker. When it hits to end of file marker, then each terminates, because it processes the whole enumerated set of objects. Enumerated objects are lines, and then you finish the program. It is also possible to append. Append is this operator, same as insert in stream in C++. So you have A, which is 0, 1, 2, 3, and we are appending 4 and 5. When you print that, you get 0, 1, 2, 3, 4, 5. So this appends to the end of an array. Uh, However, you can append to standard output. So std out is literally stolen from C, the C operation. What you can insert inside, whatever you want, whatever comes in C. So I'm inserting new line, and then this array A and new line. So after that, inserting that in standard output, I get it here, 0, 1, 2, 3, 4, 5. Of course, when I insert that without spaces, I get all glued together. It looks ugly. But if I put 7 deadly sins that I insert one after the other in standard output, then here is space, here is space, you get 7 deadly sins here. Or you can have loop in which you have 0, 0, 1, 1, 2, 2, 3, 3. So you are making the loop and read each with index. So what I'm having here, creating file new for writing, then a length times insert in file a of I, a new line, and then read it with each with index and display what is inside. Create file, read file. Same as in each language, nothing new, nothing particularly specific, just you have to know that it has a little more. Those of you who are very much liking this to be like C out, insert 7, insert deadly invert sin, you have it here, same as in C++. If you like this, it is not C out, but it is standard out. So big deal. Numeric methods, you have fantastic support for mathematical methods. So recognizes rounding, absolute value, infinity, logarithms, everything is available. So trigonometric, hyperbolic functions, everything else. Here is example of working with rational numbers. So with rational numbers, you can have plenty of things that you can do with numerical values and with rational numbers. You require rational and this math. And then when you do that, you can have, for example, penny, that is 1 over 100. Nickel is 5 cents. Penny is 1 cent. 5 cents, 10 cents, quarter is 25 cents. So you say, what is quarter plus dime plus nickel plus penny? And then you get, for example, 41 cents. Or you can ask, is 20 nickels equal 10 dimes? And the result is 0. Yes, it is. Okay. How much is 4 quarters? 4 quarters is $1. Okay. And then you can do all these other operations with rational numbers. This is very important if you want to have accurate results and not something that is a rounded real number. Another thing, you have plenty of opportunities to do precise time measurements with time class. And here is example of measuring operations that are rather fast. So if you have something these microseconds, you can do that using this trick here that you can learn if you take performance class. I'm going not to do that here and now. And then we have matrix operations that give you everything that you can do with matrices. You create matrix, first row, second row. If this is first row, second row, then you can compute determinant of matrix. M1 determinant, it is 1 times 4 minus 3 times 2. So it is, determinant is minus 2. Determinant is minus 2. You can ask whether the matrix is regular or singular. You can have rows and columns. You can perform inversion of matrix. M1 inverse is going to invert the matrix. Pay attention that you must use real numbers. If you put here integers, everything is going to go to wrong values because to compute the inverse matrix, you have to divide a joint matrix by determinant. So you have to find a joint matrix and then divide by determinant. The determinant, a joint matrix, an integer is going to be integer division. The result will be wrong. You will not get the inverse matrix. So pay attention that you must put here real values. Be careful when you program with dynamically typed languages. With dynamically typed languages, you cannot put inside whatever you want and then somebody will convert for you. You have to put exact values. Multiplication of matrices is, of course, asterisk, multiply matrix time matrix. And matrix time matrix inverse, what is going to be obtained? You're going to obtain, of course, the unit matrix. You're going to get 1, 0, 0, 1, matrix times matrix inverse. So you have the complete linear algebra here, which is fantastic. No other language gives you all this completely written so that you just have to use it and use it in such a way. Multiply matrices by putting times. That's fantastic. That's absolutely opening a new world of simple and easy, elegant programming to have fun. Complex numbers are available, and you can solve equations with complex coefficients. And this is also something that is very important for everybody who wants to do Laplace transform and do solving partial or any differential equations using complex calculus. This is very easy with complex numbers that are supported here. So Ruby supports multi-paradigm programming. It supports procedural programming, it supports functional programming, it supports object-oriented programming. And all languages of the future, you can expect that will be multi-paradigm, will support procedural, functional, and object-oriented. Logic programming is a different thing. This is more or less language-oriented programming. What Racket tries to do as the fifth paradigm. To what extent is this going to happen? Nobody knows, because it is not simple. It needs programmers who can create new languages. But this is one of way forward. Procedural, functional, and object-oriented is supported. Basic data types in Ruby, integer, float, complex, rational strings, and characters. It has procedural programming supported with 30 different control structures. So you name it, we have it, everything here. It supports functional programming because assignments are expression and return value. Sequence return the value of the last expression, same as in scheme. Control structures return the value, same as the scheme. Mapping an expression to a collection of objects is something that is same as in scheme. Support for functions with arbitrary number of arguments with splat operator, yes, we have it. The list structure of functions, you can write it as operator, operand, operand, operand. You can say mean value of 1, 2, 2, 3, same as in scheme. So tail recursive functions can be made with tail and doing tail recursion. So all this is similar to what we have in scheme, in functional programming in scheme. Ruby supports object-oriented programming. For example, you can create a class box. You are open and add methods to class box. You can take class box and create color box by inheriting from box and adding color and weight. And then you can also do other similar things. So highlights and conclusions are Ruby's multi-paradigm language. It is dynamically typed. It is rich, has more than 9,000 methods that are available. It is a relaxed approach to syntax. You can write in various ways and Ruby will understand you, no rigid rules. It is strictly object-oriented, 100%. It has simplicity. It is free and it is growing. You pay nothing for it. It is good for web application development, and it is performance aware. It has benchmark programs, and it has various engines that are applied. So virtual machines, YARV and Ruby works with Java virtual machine, etc. It has tools, debugger, profiler, and much more. Next steps are Ruby on Rails for defining various applications. And that is all what we have in Ruby. The next thing that I would like you to see are slides that are preparation for the final exam. I posted this on iLearn, and I hope that you received the email that came for that. So preparation for final exam, which is online, is certainly slightly different than from face-to-face. So rules are that you have open book notes computers. You can use everything, and please have the reader next to you, because you can use things from the reader. If you forget some syntax or something like that, you can easily find it in the reader. So individual work only, everything else is illegal, or your answers must be verbally explained to extent that proves that the solutions are your intellectual property. So tell what you want to do, or put comments inside. This is going to be convincing way for the grader to know that you have done that. Solutions without convincing explanations are not acceptable. If somebody takes a piece of code from somewhere and put inside without any explanation and so on, there are going to be, of course, no points for that. Search and use of the internet resources during the exam is not permitted. Therefore, we are going to request that our question 1, to have a honor pledge. So the prerequisite is going to be question number 1, and there are going to be 4 more. The prerequisite for passing this exam is that in the answer area, you provide the following honor pledge. You say, I, Jozo Dujmovic, declare that the answers to all questions in this exam are the result of my own work, obtained without help of other people and without access to the internet. I understand that all questions are copyrighted and confidential, and I pledge that I will not copy and distribute the questions. So this is your honor pledge that has to come as the first question. Copy this and put your name inside, and you declare that you are going to do this in the way that we are supposed to do things. And honor pledge is an important thing. Then we have other questions. In face-to-face, we have also theoretical questions, and this is not going to be used in online exam because it is just copying from the reader. However, there are short programming assignments in Scheme and short programming assignments in Ruby. Typical number of questions is 4, which is 4 times 30 minutes for 2 hours. So there is plenty of time that you write your program and write description of your program. All comments and descriptions give you partial credit. This is not just for grader to understand, but it is also important. So Jorge, unmute yourself. Don't raise your hand. Ask question, interrupt at any time. Go ahead.
I was wondering, it says right there there's going to be short programming questions on Scheme. I thought it was just going to be on Ruby, or is Scheme now included as well?
No, you have 4 questions. You have them here. So let me show you. In the case of Scheme, you have theoretical questions that are not going to be used. This is for face-to-face. And if you have short programs, sample Scheme programming assignments. So please read this from this file. File is posted on iLearn. So read it. Here is an example. It said here is write a Scheme function count number of elements in the list. So how many times you have this element in the list? And this is the solution. So it is a short program, similar as Scheme program in the homework assignment. Then here is make the histogram. That was your homework by making first line and then recursively use this line in histogram. So here is your program, blah, 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 blah. And how to do that with vectors, with lists, etc. So read this and read the solution. It is solved here. So these are typical problems. Is this understandable, Jorge?
Yeah, but I guess more of my question was if Scheme will be tested on the final, or if it's just going to be Ruby. I know these are examples.
It is
okay. Just wanted to make
Scheme sure. Plus Ruby, okay. And nothing more. No, this is, we finish procedural programming, no questions about that. We finish Ruby, no questions about that. We are working only on 40 points that remain unassigned and nothing else. So it is strictly questions from Scheme, and after that, questions from Ruby. So here we have Ruby, theoretical questions, no theoretical questions, but there are going to be sample Ruby programming assignments. So one of them is this one here. You have a sphere, and then you make a sphere that is used to inherit, to create the ball. And then there is the name of the kid who is the owner of the ball. So you have my ball, it has radius 1, it is red, and owner is Ted. So this is a typical object-oriented little program that you are going to have on final exam, always one of this. You can also have something like this set that we played with a minute ago, or some numerical problem, like here is make all prime numbers between 1 and 100. So these are prime numbers that you have to write little numerical problem that find what is a prime number. It is not divisible with any value. And sometimes there are also general questions, but not this time. So read this, and this is going to give you the idea of what's going on. Another thing, people usually ask how to grade this. Is this going to be graded on the curve? Yes, yes. Everything is explained in frequently asked questions. So what's going to happen at the end? We are going to take these points that you accumulate through final exam, and we'll append this to these points that you have from previous exams and from homework. And then we are going to get the ranking, the same ranking as those that are posted on iLearn. And then in that ranking, whoever is in the middle of that list gets the middle grade, and the middle grade is C+, for example. So if you are above this middle, you get B or A minus or this upper grades. If you are below the middle grade, you get C minus or D, or the minimum passing grade is D minus. You can graduate with D minus if you want, because this is not prerequisite for any other class. Therefore, you don't need to have big, except for graduate students. Graduate students must have B or better, okay? But all undergraduate students can have any other grade. That's not the problem. Now, if somebody did nothing and didn't take exam or something like that, this is going to create F. But this is very small number of people, and I hope that you are not going to be there. Let me have everybody passing, if at all possible. I cross my fingers, okay? That's the first thing. Second thing, the point of this class was to show you procedural programming, logic programming, functional programming, and object-oriented programming all in one comparable class. So now you have your knowledge of these 4 paradigms, and you can claim in your resume that you are familiar with these different paradigms, that you are going to recognize them in new programming languages, and that you are going to be able to use the languages that are using these paradigms. And this is widening the bag of tricks that you have in your professional work. And this is the purpose of this class. So it shows you all variety of paradigms that we have in programming. And therefore, that's all what I can say about this class, except thank you very much for taking this class and for participating in it. Now, if you have questions, please ask now.